The first topic I'd like to talk about in solving circuits is how to deal with a basic series circuit. Now, the first thing we're going to talk about is Kirchhoff's law. In Kirchhoff's law, it basically says that the voltage of the source is equal to the voltage at every spot along the circuit. And that current is the same at every spot. So let's take a look at this example here. I'll put a battery in here, and I've got resistor 1, and I've got resistor 2. So if I told you that the voltage here was 6 volts, I could tell you that the current, that the voltage right here is 4 volts. By definition, the voltage here has to be 2 volts. Now, if I told you the current here was equal to 2 amps, then by definition, the current right here would have to be 2 amps. And the current here would have to be 2 amps, because the current adds up everywhere. Now, a little bit more of a derivation, review of resistance laws. Ohm's law states that resistance is equal to voltage over current. Naturally, we could also rewrite this as saying voltage is equal to current times resistance. Now, if I took this and I plugged it in to the first Kirchhoff law, which is voltage total is equal to voltage 1 plus voltage 2, and so on, well, that would look like current total, resistance total is equal to current 1 times resistance 1 plus current 2 times resistance 2, and so on. Now, we learned a second ago that the current is the same at every single point in a series circuit. So really, we can get rid of this. It'll all cancel out. Therefore, in a series circuit, total resistance is equal to resistance 1 plus resistance 2, and so on. So the resistance of the source, wherever the power is coming from, is equal to the resistance of all the loads. So if you want to try an example, I hit pause on the video to draw this circuit up. Now, what you should be able to do at this point is, with the information given, you should be able to figure out the remaining values on this. And it will come from knowing our resistance formula here, our formula involving current, and our formula here involving voltage. So hit pause on the video, try to solve it, and come back. Okay, what do we know from here? We know that we've got 6 volts at our total. We know that the first resistor has a voltage of 3. The third resistor has a voltage of 1. 3 plus 1 is 4. 6 minus 4 means this has to be 2 volts. What else do we know? We know right here the resistance is 2 amps. So therefore, it has to be 2 amps here, has to be 2 amps here, has to be 2 amps here. Now, if we think about Ohm's law states that voltage divided by resistance, or voltage divided by current, is equal to resistance. 6 divided by 2 is 3 ohms. 3 divided by 2 is 1.5 ohms. 2 divided by 2 is 1 ohm. 1 divided by 2 is 0.5 ohms. 0.5 plus 1 is 1.5. So these two plus this one is 1.5. So we're up to 3, a resistance of 3, which is also the resistance at the total. We've proven that the circuit makes sense.